Okay, so welcome to my all students and learners. So basically, I am going to start because today there is a trend of artificial intelligence, uh, data mining, deep learning, machine learning, all these things. So definitely, it's a emerging trend, and in my opinion, within next 10 years, 75% of enterprise applications will be dependent on this AI and machine learning. So, in that aspect, I thought I will start this course to give you a very brief knowledge and how it can be implemented in your day to day life as well as in your working field also. So first will this the first lecture is just give you an idea. Slowly I will uh, touch the in details. I will go with the with example and coding. I will explain. I will teach you, and each lecture, after each and every lecture there will be a assignment. And because as it's a online course, so some people maybe they will be different part of the country, so it is difficult to get access them directly. So after each and every lecture there will be one assignment. It will be in that this the video, or at the end of the lecture the assignment will be given. The next day you have to submit that. You can do in your notebook, then by writing you can send it me back. That will be your assessment, and based on that your finally the certificate will be issued for this course. So basically, machine learning is nothing but to train a computer to work as human. Like, you know, um, uh, in our college days, because basically I'm a technologist, I'm an engineer, so I can talk about more about that. So we learn the fundamental, we learn the mathematics, but when I came to working field, then automatically I am applying that knowledge where to be applied. Means I'm implementing the things based on my learning. So machine learning, it's a human learning process. Okay, you learn, apply, execute the job. So the same way, this machine learning, basically we will train a computer or a machine that it will work as a human. When mother taught a baby to write ABCD, it was not looking nice, because that's the first time. And repeatedly, when the time elapsed, the shape of the alphabets, it is looking good based on the training over the time. Okay. So similarly, in case of machine learning also, you can feed the continuous data over time to increase the accuracy of the system. You can feed, say there is a real time data you are feeding, and you are improving the system. Okay. So in a single word, basically you are feeding the data. There is no certain like an expert system. There will be no formula, nothing like that. Okay, you are feeding the data. Like, you see, you are when you see a dog, there are so many animals, but once you are seeing the dog, you can very easily identify this is the dog. Like, we are seeing so many animals after our birth. We are seeing so many animals and characterizing. Once I see the dog, immediately I will identify it. Like, we are improving. Like, when a baby, initially he may not understand the name of the flower, but when the time elapsed, he is getting trained, then easily he understand what that flower is. Likewise, we can increase the system over the time by feeding the repeated data. In case of coding, what we do, uh, first we will identify uh, what is the assignment. Say you have to find out, there is a say there are two numbers, you have to add it. So when these things you will be going to execute through by writing a coding. So what we will do, we will identify what is the input, then the programmer will start to write the code based on some algorithm, is apply some formulas, and the output will come. This is applicable for a particular very specific assignment. But in case of machine learning, you have to take a huge historic data. Today our computational capability is very high. It's very high. Let us people are not bothered about to develop a very precise sensors, because it's based on the sensing element. You need to have a very thorough knowledge about the material science to develop that particular sensor, how it will be responding, its accuracy, all these things you need to do. But today our computational capability is so high that let take it keep it aside, and you can take some inaccurate data. From the inaccurate data, you do the trending, you eliminate the error and get the actual value. This is the job done by machine learning. Okay, so in case of machine learning, the huge historical data is taken, is captured, and with that a system is modeled, so that for for the same application, if sometime later if any data is coming, the trained system can execute the actual output. Like, you can take an example. Nowadays every search engine, like our Google Chrome or any search engine, it's a back of that some they uh, continuously try to model a person who is surfing the browser. You can observe that they are trying to model you. You can test it, you can verify it. What they will do, this browser, the backend, the machine learning network, what it will do, over a period, say over a year, you are searching some January month, maybe you are searching more fruits. February month you are searching clothes. April, like that, they will continuously model a person, that over the time what he is trying to do. Then if you open any your e-commerce site like Amazon or something like that, where you need to purchase, automatically before typing in the top, you can see that things it will be displayed. what actually you are trying to uh, find, trying to search. So this is basically a an very popular example of machine learning, that most of the today's search engine, they will uh, try to observe you in the captured your search data, and based on that they will model a particular human, and it will be applied in so many other businesses, your all the real life needs, everything. Okay, so here, to capture the data, unbiased data, here the if the data you are capturing to train a machine, train a model, if it need huge data, and it should be unbiased data. Unbiased data means, if you only taking the data, say you are taking a data for to model a person, if the search engine is taking only the data from a particular month, then this model, after training, this model is not applicable for other months. So that is a biased data, so you should not take the biased data. Random unbiased data you have to take, and huge data, so that later on, any particular case, it should be a subset of that data you have used to train the network. Okay, it have a this machine learning, uh, why it is getting popular, because it has a wide range of advantages. It can solve very complex and nonlinear problem. Especially I am an electrical engineer, so I can talk about that. You know, when you need a very precise output from a system, so there are two type of system in everywhere in human life also. So if you give the excitation to the system, according to the excitation, the output, it will, the system will exhibit the output. But once you want a very tight control over the output, then this kind of system, which is called open loop system, is not suitable. Each and every moment you have to take the feedback from the output, and each and every instant you have to check whether the output is desired as I was expecting. If it is not, based on that you have to vary the excitation to the system. Like our car, if there is you can think, if there is a no speedometer in our vehicle, then how we will control the speed? Just like that, we will do something and it will go, but there will be no tight control over the output. Sometime to do this, to control the excitation, because you need to have the control on the excitation also, otherwise it will, there will be overshoot or undershoot in the output. So to do that, you need to model the system which you are operating, like car or something like this. But this is a very complex problem. Inside it have the nonlinearity. So this, if you, in a nonlinear system, if you want to have a very dynamic high performance response, you need to design some controller which can take nonlinear gain factors. It's a very crucial task. The classical control talk about PID or PI regulator. Who are engineers, they might be aware, but this is a very difficult thing. So the machine learning based, basically it's a model free adaptive control. Once you are implementing the system or the controller based on machine learning, so it can take nonlinear gain factors, and your entire system will be, the control will be a model free adaptive control. So it has a wide range of advantage. Likewise, everywhere there will be a disadvantage. So the data acquisitions, I will also, this is there is a very important application of the machine learning today. I think few years back I talked with some medical consultancies. So they are trying to find out the remaining useful life estimation for some organ like our heart, liver, and all these things. You have to take the real time data, and based on so many data for a heart, you have to take, say, your cardiac output, your BP, amplitude of your PQRS complex, the ST wave, PQ wave, then like that, so many parameters you have to observe, and from that you have to train a network that when there will be a possibility of some problem in the heart. Okay, so this the remaining useful life estimation is a very important application nowadays in everywhere, in a mainly the the medical applications, the crucial engineering like aeronautics, nuclear space applications, all these things. So I was talking about the disadvantage. So this, because you need to very careful about the, for a particular network training or implementation, what kind of data you need to capture. Okay, and that sampling time, what interval you need to capture the data, all these things, it's depend on your practice and knowledge and experience. There might be some when you are capturing the data, the if there is a error, then your entire network will be wrong, your training will be, it will give the wrong output. Then there are several algorithm to train the network. Okay, so for a business model, for a healthcare application, for engineering application, what kind of algorithm you are going to select, that is a very very important thing to uh, make your model perfect. And it's a definitely, it's for a big network, as it is, as it will compile huge number of data. So this is a time consuming process. So with this, just I given a very basic idea what is machine learning. So I will start with the machine learning, the packages which I'm going to use. I will teach you from the scratch, but you need not to worry, because in this course some non-technical people are also there. So I will make the thing so comfortable. Just if you follow me, you will be able to execute the task. Don't worry, I will start from the scratch, so that it will be not difficult for you. Okay, I will start with very basic machine learning, the packages, what are the packages, how to install, what are the libraries. Like we are going to machine learning, we'll learn using Python and using few libraries like Panda, TensorFlow, Keras. Okay, then we will learn very basic mathematics which is needed for it, like your statistics. Probability and statistics is a very important part of mathematics which is applied in this artificial intelligence, machine learning and deep learning. Linear algebra, and calculus, both are equally important. Then we will go to deep learning. In case of deep learning, I will, because it's a very short term and very basic course, so I will use MATLAB. I'll give a introduction of it, because in MATLAB so many libraries are inbuilt. So in case of, deep learning is basically based on neural network, mainly in convolution, CNN, convolution and neural network. So there are lot of libraries are required, otherwise you have to write the subroutine. So to uh, shortcut the time, I will use MATLAB. And later on, if somebody interested to continue the same using Python or this kind of libraries, I will be there, no problem. Okay. So with this, today's ending the today's session. So this was just about uh, to give you a idea about the course, what I am going to do. So I will request, if it is possible, uh, if the time permits, you just brush up very basic things about Python, how to write the code, syntax, uh, then very basics of probability and statistics, the linear algebra like determinant matrix, and very basics of calculus. Then it will be very easy for you to catch it. Thank you. So, and the assignment I will be writing in the description, because this video I am going to upload in YouTube, and the today's assignment will be uh, written in the description of the video. So you just submit it tomorrow. Okay. Thank you so much. Thanks for your patience.